Are you able to see my screen? Are you able to see my screen?
I can see it from my end.
Okay. So I'm presenting the introduction to spatial analysis in R. Yeah, so spatial data analysis is the process of examining and interpreting patterns and relationships in data that have a spatial component. It involves various techniques and methods that are used to understand the spatial distribution of data, the trends, and the predictions. So spatial data analysis has been used in different apps, in different avenues. For example, in tracking of food deliveries, we can use GPS to travel. We can use apps like Safe Border, Safe Car, Uber. All those ones have incorporated AI into spatial data and hence being able to deliver in terms of that. So some of the apps include like Safe Car, Safe Border, Google Maps, we have Google Earth, we have Uber, we have Airbnb. It also uses location to show which particular accommodation facilities we could consider and all that. So we have two types of spatial data. We have the vector data types and we also have the raster data types. And under vector, we have the points, the lines, and the polygons. And for the points, usually these points represent like roads, rivers, boundaries, and all that. If you have the Google Map app and if you could look at it, you will see that they are points, and those points indicate a location, a place, a hospital, and all that. So those points are under vector data types. And also we also have lines. These lines can show boundaries, they can mean rivers, they can mean, they can mean roads, they can show where a particular area.
Process, just a minute.
Yes.
Agnes, can you unmute?
No, this is Calvin. Let me edit the name.
Yeah, I had put you out and I've sent you a message and you're not replying.
I've been trying to reply, but it's not working.
Yeah, please just rename yourself. Sorry about that.
Right.
Yeah, you proceed.
Yeah. Do people have a Google Map app? If you have it, then you can open it so that you can clearly understand what I'm talking about. And then for polygons, so we have points, and then when these points are joined together, we have lines, using lines, and then when these lines are joined together, we have polygons. And so these polygons usually show areas, they show countries, they show lakes. You can look at roads, and when these roads are covered together, they show an area, like a location, a village, like that. So usually for vector data, we usually use spatial coordinates. For those that have done data collection, you have collected GPS coordinates one time. So all that falls under vector data. And vector data is mostly used in GIS systems. Yes, GIS is also used in prediction and analysis of spatial data. So these are the types of, these are the points. So these are all types of vector data. Like you can see, this is the point, that is how it looks like. And when they are combined together, they make the lines. And when these are combined together, they make the polygons. And then we go to raster data types. Raster data types are mostly pixels, or they are a matrix of cells. They are organized like rows and columns, and each cell contains a value representing information. We can look at this, for example, information like temperature, elevation, and all that. So rasters are digital aerial photographs. They could be digital aerial photographs. They could be images from satellites. They could be digital pictures or even scanned maps. And our raster data models consist of two categories. We have those that are continuous and discrete. So I don't know if people have heard of an app called Google Earth. You could download it and look at it. Please, by the show of hands, you could show me if you've downloaded Google Earth so that you can clearly understand what raster data type is. Has anyone been successful with it? Calvin? Okay, let me continue. So if you're able to download the Google Earth and the Google Map, you'll see the difference. For the Google Map, it shows mainly things like points, things like lines, things like polygons. But when you look at the Google Earth, it will show you a pictorial image of a location or an aerial photograph of a location. Yeah, so the two are quite different from each other. So this is how raster data type looks like. Or like when you look at the Google Earth, it will show you like a picture like this or a picture like this. And all these pictures signify something behind them. The difference between raster data and any other pictorial photograph of a location is that, or an aerial photograph of a location, is that for raster data, there are coordinates behind it. And these coordinates all mean something, or all these coordinates explain something in regards to that particular raster data. So raster data is stratified into two forms. There is continuous raster data, and then there is discrete raster data. For continuous raster data, it is mostly numerical. Just like you can see here, we are looking at raster data that looks at the Harvard Forest Field site. And for it, it's actually numerical. It's showing the elevation of the trees and the forests. So for it, it's mostly numerical in nature. And then when you look at the discrete data, for it, it is distinct. If you've looked at, if you've analyzed categorical data before, you will know that we have that data that is categorical and we have that data that's continuous. So we can relate the continuous raster data to the continuous data that we usually use in analysis. And then we can equate the discrete rasters to the categorical data we use in analysis. So for discrete, it's mostly categorical. And then also we can change continuous to categorical by stratifying. We can say from maybe 50 to 100, it will be this category. From 100 and more, it will be this category. So it's possible to change the two raster types. And then we also have, so there are things we consider when we are choosing either to use raster or vector data. For example, we can consider storage size when we need to handle something. For example, when we are handling something and then we are sure of our storage size or our storage data, or we need to handle little quantity of data, then we need to consider vector data. But if you can handle a big storage size, or if you have a big storage size, then you can think of handling raster data, because raster data is more complex and a lot. So that's when you can use raster data instead of vector data. And if you want, if for the nature, you can also consider the nature of the data. And raster data usually works with continuous data better. Then if we've showed that it has the continuous and the district, but raster data works more with continuous data. And then if you're looking at district data, if your data is a bit district, or what you want to study is a bit more district or categorical, then you would want to consider using vector data. And then if you're looking at precision and accuracy, all of them have a good precision, though vector data is known to have a higher precision compared to raster data. And if it could also be considered using the nature of analysis, if you're looking at topological analysis or geometrical measurements, then you will have to consider using vector data. And then if you're going deep into spatial modeling, then you'll have to consider using raster data. And then we have something called an attribute data. This is not a spatial data type, but then it's something that is used when we are analyzing spatial data. So for attribute data, it gives us an explanation of any spatial data. For example, like the figure, like for example, this figure here, we can have attribute data that explains like every single point that you pick. For example, if you select a particular point, it will show you what is that location, what is the street, you know, what are the temperatures there, what is the height, and all that. So for attributes, it gives an explanation of a spatial data or a spatial location and all that. So it can the attribute data can explain a data point, it can explain the lines, it can explain the polygons, or it can also explain the aerial photographs that are under the raster data. So it can give any kind of description, it can give text, it can give a numerical description, it can give anything in description to the spatial data. And then in continuation, we have something called topological analysis. So in topological analysis, we are looking at the relationship between the different data types. Like we said, we have lines, we have points, we have polygons, and then we have the aerial photographs and raster data. So by then there is a relationship between the data types. And so topological analysis is the study of the relationship between the different data types. So the data types could be adjacent. Here, it shows that two spatial objects can share a common boundary or edge. So for example, two polygons, they could be connecting via just a small line, you know. And then there's also containment, where one spatial object is completely contained within another spatial object. We can have a polygon inside another polygon. So that falls under containment. We can have two spatial objects share a common point or intersect with each other. So we could have two polygons or two lines, and they have a point where they intersect with each other. They may not be completely inside each other, but they could have a point where they intersect. So that is what we call intersection. And then we also have connectivity. Here, spatial objects are connected through a continuous path or a network. So here we could have our two polygons, for example, A and B, and we have a line that connects the two spatial data types or the two polygons. So that's when we have the connectivity. All these will be useful in our future lectures in regards to spatial analysis. So this is an example of what I'm talking about. For example, here A and B. A is inside B. So this is what I was calling the containment. And then we have A and B where there is a particular, for touches A and B, we have A and B where there's a particular line where these two polygons intersect, and this is what I called the adjacent, or it could also fall under the intersection. And then we have also A and B. Still, these A and B is a line, and then A is a polygon, but still there is a boundary where these two intersect. So it's also a relationship, then crosses, these two lines intersect. So this falls under intersection. And then crosses A and B. This also falls under intersection, and overlap A and B. It also shows where polygon A and B intersect at a particular point, but it's not entirely inside another polygon. So all this knowledge will be useful later in our study for the spatial analysis. And then another spatial concept that you need to know is spatial modeling. Here we shall model using mathematical concepts to simulate, predict, or analyze geographical processes. And then we shall have spatial autocorrelation. If you know what correlation means, where we are studying the relationship between, for the normal analysis we usually do, we study the degree of relationship between two continuous variables. But here for spatial autocorrelation, it refers to the degree to which two spatially adjacent or nearby spatial data types, we study to which degree they are similar to each other. And then for spatial interpolation, it's a method used to estimate values of a variable at unsampled locations within a geographical area using the sampled locations. Like, it's a way of getting a value by using the locations that already have values. So yeah, but all these concepts will be used in our sessions that we shall be having. Yes, so do you have any questions in regards to this?
Yeah, Prose, maybe I can go first.
Okay.
Yeah, great presentation and great introduction. Where do you think we can apply the spatial data analysis skills in our real life or in our day-to-day work that we do?
We can use spatial analysis skills in, for example, we can use them in follow-up studies. In studies, when we are collecting data, usually in research, we also collect GPS coordinates. And usually those GPS coordinates are the same coordinates we use when we are doing our follow-ups in order to be able to locate the respondents that we had interviewed the previous times. Spatial analysis can also be used when developing the apps that I showed up there, like the Google app, the Google Maps, the Google Earth. They all used all this knowledge of spatial analysis and incorporated in AI in the same. And then we could also use spatial analysis in the times like the epidemic times, spatial analysis. For example, you can use spatial analysis to, using the data available, you can use spatial analysis to display or visualize which particular places are highly endemic and which particular places are predicted to get endemic or to become endemic in relation to a disease that is being studied, and many other fields. Anything regarding location can be done using spatial data analysis. Vicky, I cannot hear you. Do you have any other question in regards to what has been presented? Okay, so
Yes,
I
boss.
request. Okay.
I have a follow-up on your previous page, slide.
Okay.
You just go back to the previous slide.
Okay. Is it that one?
No, the one that was talking about interpolation.
Oh, okay. Yeah, that one.
So I wanted more clarification on interpolation and modeling vis-a-vis autocorrelation. I thought initially that autocorrelation can form part of interpolation, but I'm not sure. So I wanted to get more clarification on this. Because when you're trying to get estimates for unsampled areas, does autocorrelation come as part of the steps towards interpolation?
Okay, so here we are just presenting the different concepts that will be used in regards to spatial analysis, so that people don't find them new as they are studying them. So I do not have a particular order that I followed. I just wanted people to know what all these things mean, so that when they are being stated in the preceding sessions, they're able to understand what's being done.
Thanks, Pros.
Yeah, thank you for that. So if there are no other questions, then we can have a session of 15 minutes so that we can invite in the other presenter. So you can have 15 minutes to rest as we invite in the other presenter. Also, if possible, you can open your R software so that we can have a practical session so that you can be able to see how raster data looks like in R, how vector data looks like in R. So you can open your R